All right, and then my name is Mr. Bing. It is October 27, 2020 at 1:38 p.m. This is fourth block, and we are in Principles of Engineering. And my friend Cody has asked me if I would go over one of these problems. This is assignment 214, calculating force vectors. And so I'm not even looking at the procedure steps. I'm only looking at the problems themselves. So there's 1, there's 2, there's 3, there's 4, and there's 5. I'd like to do this one because it's the hardest one out of the set. And so I'll set this up, and then I'll make my screen over here bigger in just a moment. But this is POE. What's it? 2.1.4. Problem number 4, I'm calling it. I don't know what step it is. But anyway, when you look at a problem like this, all I care about is solving everything. And so when I'm looking at this, I see that I'm gonna draw an XY coordinate plane, even though I'm not quite sure it's shown, at least not shown very well in the problem. I'm gonna put an X there and a Y there. It's a good idea to give yourself like a framework to work from. And then here is, I'm gonna base my force vectors out of that origin, and there's 2 force vectors. There's one that goes kind of up high diagonally, and then there's another one that goes kind of down low, but they're also diagonally. And then the first one is, it's G, they call it, instead of F. They are forces, but they call it G of 100.0 newtons is the standard scientific unit of force. It's unusual to see that in, whoops, I didn't say what, that's H. That's H. H equals 50.0. You don't often see newtons in engineering. More often, you see pounds. If you're more used to that, it's 20 degrees right there. I will make this bigger in just a moment so you can actually see what I'm writing down here. 15 degrees there. And so what are we supposed to solve? And the answer is everything. By everything, we mean all the component forces, which I'll show you, all the component vectors, which I'll show you in just a moment, and then the sum of all those vectors in the X direction and the Y direction, and then the resultant of all those forces when you put them all together. It is as confusing as it sounds. And so I will try, if none of that made sense, let me see, stop share. If none of that made sense, I will try to make it make sense right now, or make an attempt for that. So in this problem, without really having a question, the vector problem has to be solved. So it has to be solved. These are air quotes that I'm doing. It has to be solved, meaning we have to know everything about it. So it's not even necessary for me to put F sub r equals question mark, but that is the ultimate goal, is to find that resultant force. Each of these forces, G and H, can be combined to give you a resultant force, like the net force or total force after you put them all together. But it's not that straightforward. You just can't take a 100 and a 50 and add them together to get the resultant force of 150. It doesn't work that way. And the reason is that we've got the directions are a little bit more complicated. If they were both in the same direction, then you could just add them straight up. Or if they were exactly opposite directions, well, then you would just subtract one from the other. But because they have these peculiar angles, that's what throws everything off. So what I'm going to do is sort of focus in on one of them, and then focus in on the other one separately, and then sort of piece them together. So this G, the first one, G, that's right here, that one, the G, and I guess it's G, right? That's what it's called. The G is going to have what we call a horizontal component. In other words, how far does it go, at least on the page, on the model, the free body diagram, I think they call it. How far does it go horizontally? And then also, how far does it go vertically? And we call the horizontal one G sub X because the X on the coordinate plane is horizontal. And then we call the vertical one G sub Y because Y on the coordinate plane is vertical. So what I want you to know about these two force components is that they don't exist on their own. They are like the children of this overall G force, that you got a little one and a little one that come from the original big G force. And that is, I'll just go ahead and remind myself, that is 100.0 newtons. Now, because I have enclosed that vector in that fashion and made a right triangle with the G sub X and the G sub Y, enclosing in that fashion means that I need the angle theta right there. And the angle theta right there is not what was given. The angle that was given was 15 degrees. And I hope you can see that that angle theta, which I've labeled, is not 15 degrees. However, if I can do this very lightly so you really can't even see it, that 15 that's right there and the theta, which we don't know, they have to add up to 90 according to, I don't know what, supplement, complement, something like that from geometry class. So anyway, if you agree with that, then the theta would be 75 degrees because the 15 plus 75 is 90. But then we can just forget about that 15. We don't need it anymore. Or you could
figure out, like, forget the middle triangle and figure out the one with the 15.
Right, we could have, and what Jess is talking about, we could have enclosed it this way, which would have been perfectly legal, however, not preferable, at least in my opinion. If we enclosed the triangle this way, we still would get an X component and we would still get a Y component. However, traditionally, or preferably by me, I always like the angle that is measured from the X of the components of the component. If you don't agree with me, that's completely cool, because what you do in that case will absolutely give the same answer. But this G sub X, if you remember the sine, cosine, and tangent business, this G sub X that I want to find first, just because, you know, X comes before Y, this G sub X that I want to find is adjacent to that angle. So if you remember adjacent, and I guess, should I list them again? Sine, cosine, tangent, remember those? And sine of theta and cosine of theta and tangent of theta equals. Sine is the opposite, I think. Cosine is the adjacent. And then tangent is the opposite over the adjacent. And this, of course, is opposite over hypotenuse. Adjacent over hypotenuse. Ignore all that. That's just sort of a background. But ignore that. Let's just focus on this particular horizontal vector. That horizontal vector. Mr. Pearson has arrived. Everyone. Mr. Pearson, you are welcome here, and you are welcome to interact. I am doing in the middle of a video, though.
That's fine.
Don't feel guilty, though, because Ms. Hoffman did the same thing to me the other day.
That's fine.
So this horizontal vector is adjacent to the theta. So I'm going to skip right to which one of these trig functions it has adjacent. Well, the cosine of theta and the tangent of theta. However, the tangent requires you to know in order to solve for the adjacent, requires you to also know the opposite, which is one of the missing items here. So I'm going to use the cosine of theta. We're trying to find the adjacent, and we do have the hypotenuse. Just trust me, Cody. You use the cosine. So in this case, I'm going to, what am I going to do? I'm going to write cosine theta equals the adjacent divided by the hypotenuse. I guess I already writ that, so I writ it again. I already wrote that, so I wrote it again. Maybe that wasn't so smart. But the cosine of theta is equal to the adjacent. Well, I just said that, right? G sub x is the adjacent. And then the hypotenuse is this. That might not be really too clear here. This long side of the triangle is the hypotenuse, and we've labeled that 100, so that's 100. And then if you're trying to solve for G sub x, according to algebra, you can take what's below in the denominator and multiply on the other side against the cosine of theta. So what I ended up with is G sub x equals 100 times the cosine of whatever that angle is, which I think is 75. And then I'm going to do some scientific calculator action. Scientific calculator, it's around here somewhere. There it is. I'm looking at it. Turn it sideways, so all the scientific functions appear. So I like to do it backwards, where I calculate the cosine first and then multiply it by 100.
Wait,
so 75. Go ahead, Jess.
Why is it 75? Because if it's supposed to add up to 90, wouldn't you do 90 minus 15, then minus 20, to the 20 there?
No, that is a good point. But the answer is no, because the only angle that we're referencing right now is that one. We don't care about this one, which is 90, and we don't care about that one, which is 15.
No, I'm talking about like in the graph that you drew.
In the graph, oh, you mean down here?
Yeah, which angle are you trying to find?
I'm trying to find the components of G. These are excellent questions. I have students who are actually engaged in this lesson. I told many of them that they didn't even have to pay attention because they have other things to do, and they're doing that, the other things, and not paying attention. But Cody and Jess are with me. Okay, Jess, you're asking about the fact that I'm looking for a G here, and it's 15 degrees from the vertical Y.
Which angle are you trying to find?
Which angle am I trying to find? This G triangle, or this G vector, when I broke it into this, or when I contained it within this, I took the 15 away from the full 90, if that makes any sense. And then I got the 75 here. And then, so this 75, this theta, is sort of the reference angle that leads me through to the G sub Y, which is now the opposite of theta, and the G sub X, which is now adjacent to theta. Does that make any sense at all? Oh, okay, great. So now I'm going to do this backwards. Cosine of 75, which I punched into my calculator, and then I got a 0.258819045102521. And then I multiply that by 100 because the 100 is stuck right in front of it. And now I get 25.88. I think 25, actually it's 25.88190451025208. I think 25.9 would be satisfactory there. That is the value of G sub X. That is the value of G sub X. Now, Cody, remember I said you got to solve for everything? That's just one of the everythings. We also need to solve for that G sub Y, but I'm going to show you a shortcut. I'm going to show you a shortcut. G sub Y is going to follow the same pattern algebraically, except it's not going to be cosine. This one's going to be sine because sine is the opposite of the angle. So I can sort of cheat because I know the algebra is going to work the same way. The only thing different is going to be cosine will become sine. So look what I can do. 100 sine of 75. I go to the calculator, 75 sine, I can't see it, sine times 100, and I get a number that's 96.6, because I'm rounding it off, 96.6 newtons. So that's good. Now I have both of those. That's excellent. However, I did say we had to solve for everything. And so now that the G has been resolved, they actually call it resolved instead of solved. They call it resolved. Now I have to do the same kind of thing for the H. Remember I said I was going to separate them. So now I'm going to bring the H out. H equals 50.0 newtons. Whoops, got to slide it a little bit. And then this I like to have, again, I like to have an X and a Y reference. Here's the X, here's the Y. Here's the new theta. The new theta is 20. They gave us, bless you, my child. They gave us the 20 straight up, so I'm just going to use it here. And then the component of X, or I'm sorry, the X component of H is going to be H sub X. And this is going to be the Y component of H, which is H sub Y. And guess what? It's cheating time, because I already know that algebraically it's going to work. You ready to cheat, my friend Cody? H sub X is going to be equal to 20, because the angle is 20 this time, times the cosine. Nope, I got that wrong. It's equal to 50. See what cheating does, Cody? Always backfires. Okay, it's 50 because the value of the vector is 50 times the cosine of 20, and that's going to be equal to 20 cosine times 50. I'm doing this quickly so you know an error is imminent. 46.98. I'm going to make it 47.0 newtons. Now, cheating time for my man Cody. H sub Y is going to be the same sort of relationship that G sub Y was, except the vector is 50. And sine this time, oh my gosh, I almost freaked out. Sine of 20. So this one is going to be, what's the sine of 20? Sine times 50 equals 17.1. I'll take it. 17.1, and that's newtons. Check mark, check mark. We found, oh my goodness. We have found 4 things. We have found 4 things. Outstanding. Guess what? There's more things to find. Because, yes, thank you. Thank you, Chase. Thank you. Well, guess what? There's more things to find. Now that we have found G sub X and G sub Y and H sub X and H sub Y, what you have to do next is add up all the X's and all the Y's separately. Okay, so if I want to know, and this time I am going to use F, or no, I'm going to use R for the result. the r sub x is going to be equal to the g sub x plus the h sub x. So I'm just taking whatever the x's are, and I'm adding them together. R sub x is equal to, let me see, g sub x was 25.9 plus h sub x, which is 47. Oh my goodness. Okay, 47 plus 25.9 equals 72.9. Beautiful. 72.9 newtons for the x value of the resultant. And then I'm going to do the same thing for y. It's cheating time. I know it's going to be g sub y plus h sub y equals, let me see, the g sub y was 96.6. One error. Adam, how many errors can I have before it screws up the whole problem? One, actually. He said two. That was very gracious of you, Adam. But just one little error by me or you or Cody or Matt. Anyone makes an error, one little error, and it's all super wrong. So 90, I got lost. G sub y is 96.6. H sub y is 17.1. If I've already made an error and you're watching this at home or in the year 2120, trying to assess what life was like 100 years previous, if you've already seen my error, please forgive me. I'm just trying to show the process. And when I say my error, I don't know that there's an error. I just suspect with how fast I'm going and how easily confused I can be.
It's all right so far.
Oh, thank you, Jess. Oh my goodness. Thank you, Jess. Jess, I don't know if I could do this without you and without you guys giving me encouragement. So look at that. Look at that. I got an R sub X and an R sub Y. Well, I already had a G sub X, a G sub Y, an H sub X, an H sub Y, an R sub X, and R sub Y. I have all those things. I have so many things. Well, that's not it, Kevin. That's not it. There's still more, because that R sub X and that R sub Y, guess what? Those are components of the resultant force. We took two forces, G and H, and resolved them into their components, G sub X, G sub Y, H sub X, H sub Y. And then we used those components to add up all the X components, gave us the X component of the resultant, and then all the Y components, when we added them together, gave us the Y component of the resultant. And guess what I'm going to do now? That's right. I'm going to draw another XY coordinate plane. There's an XY. And then I'm going to draw the resultant vector, which I don't know what it is. I don't know what the resultant vector is. And I don't know what the theta is. In other words, the direction of that. I don't know either one. However, I do know this R sub X, and I do know this R sub Y. I know them both. Notice when we started, we were trying to solve for components. But now that we're almost done, we already have the components, and we're going to use those to sort of go backwards and get the result of those components, the sum of all those components. And this R value is the hypotenuse of a right triangle. And guess what? The hypotenuse of a right triangle can be used in the Pythagorean theorem. Remember the Pythagorean theorem? I know it doesn't look like it, a squared plus b squared equals c squared, but I promise you it's the same if you consider the r to be the hypotenuse side. And since we know the r sub x is, I don't know what the r sub x is, 72.9. Since we know what the r sub x is, 72.9 squared, and we know what the r sub y is, 113.7 squared. And then this is, Adam, where errors are going to come, because it's taking a year to do this, but I'm racing trying to get it done. 72.9 times 72.9, that's what squared means. And I get 53.14, I guess, yeah. I mean, there's more digits, but I'm like super lazy. 5,314.41. I just rounded it off to a whole number. And then I got 113.7 times 113.7, because it's squared. And this time I get 12,928. There are decimals at the end, but I don't care. Like I said, I'm like super lazy. And then I'm going to add those two numbers together, 5314 added to the 12,928. And this time I get 18,242 newtons, which is, oh, it's off the page. Why didn't you tell me that, Matt? So when I add these together, guess what I get? The resultant of the two vectors. Oh my gosh. That's not true. I get the square of the resultant. See, almost made an error, Jess. And so to get R without the squared, I have to square root it. And so I'm going to do that. 18,242 square rooted, and I get 135. I'm going to put 0.1. It's actually 135.0618006691751. And so I'm going to round it off to 135.1 newtons. Big check mark, my friends. How many check marks do I have so far? 1, 2, 3, 4. I got all the x components of G and H. And then I got 2 more. I've got the sum of the x components that give me the resultant x and y component. And then I put those together in the Pythagorean theorem, and I got the Chase. Yes, you may use the hall pass sign out log. And then the resultant of all that put together. So now we know that. We know everything except one more thing, and that's that theta, which defines the direction of the resultant vector. And if you remember before, we used sine and cosine. Well, I want to use tangent this time, and the reason is that tangent is the opposite over the adjacent, and we have the opposite and the adjacent. So I'm going to put tangent of theta equals the opposite, which is r sub y. And if I remember correctly, that's 113.7. And then the adjacent of that theta is r sub x, which is 72.9. I'm going to start sweating because I know we're so close to a correct answer, assuming there's no errors. And I don't want to make an error, like fumbling on the 1 yard line. So did you guys see the Penn State game and the guy that was short for the 2-point conversion? It was incredible. Anyway, so 113.7 divide. Okay. Yes. I'm going to go ahead and do that. Divided by 72.9. I hope you agree. That's the math involved there. And I get 1.56, which is not the answer. 1.56 is not the answer. We're trying to find that theta, and that theta is locked within a tangent function. And so in order to find that theta, I have to do something called the inverse tangent, which the way they represent that is tan to the negative 1. Tan to the negative 1 of 1.56. If you take the tangent of 1.56, you will not get the right answer. But if you take the inverse tangent, and for most calculators, there's like a second key that makes that happen. 1.56, I'm going to do the second key. Where's the second key? I don't know where the second key is. This is a little bit of a problem. Right at the end, I told you things would go kind of funny.
So what sign it is?
Okay, that's even better, right? Why can't I find the second key?
7.30.
Okay, thank you, Jess. I can't find the second. Oh, I found it. Second key, and you already told me anyway. So tell me again.
57.3.
57.3. That's good enough, and it is degrees. You could say, and it doesn't really matter. You could say 57.3 above x axis. Oh my gosh, we found it all, everything. We found everything there was to find. So, Cody, the madness that I just spewed upon the class, I'm sure was either overwhelming or nonsensical or maybe not exactly what you wanted. But if you want to look at this video, or I'll just hand you my notebook. You can just look at my notebook if you'd like to do that. And I suppose that's all. Anything else I should say, Pablo, to the people from beyond? Get back to work. Okay. And that's probably also including me. How do I stop this recording? Oh, stop recording.